and also the rise of clouds, of data access over the cloud. We feel there are some needs for an evolution of the GDS. So we discuss the main things that we have identified as possible changes for future. Yes, but first of all, I will just give a brief overview of the GRIST data discovery services, and mainly the GRIST catalog. So as shown earlier this week, we have a GRIST catalog on the GRIST website. So for now, it's a bit buried within the site. So it was on purpose because we were it was more there for assessment and for data producers to start populating the catalog. But now that we have reached a fair amount of data sets documented in this catalog, it will be moved in a more accessible way to the front page of a GRIST website. So for editors, so data producers who have to document their data set. So I remind you that we produce some guidelines, on how to edit data sets in the catalog. There was also a video conference organized at some point, and the video is still accessible also on the GPO website. So we have already populated a lot of data sets, about 146. Many of them were taken directly from the product catalog. Some of them, and still many, needs to be either updated or just reviewed and published to be made accessible publicly. But for now, there are 72 data sets that are publicly accessible in the catalog. A point also that needs to be taken into account for secondary or mirror DAX. So we talked earlier with Ken about this. You need to document the access points that you provide for the existing data sets that are already in the catalog. So it's not a new data set that we put in the catalog, but we just add new FTP, OpenDAP, etc. Links into the dataset description. So this is something that needs to be done when you, as a DAC, deliver some datasets. And also, when you have a new dataset, and I saw many of them on a Monday, don't forget to add a description, the corresponding entry in the catalog. This is the way we keep it up to date and visible from everybody. So I will do, because there were some questions on how to select data sets in GRIST. So I will do a short demo. Okay. Okay, so just to give a brief overview of the catalog. So once you get to the main catalog page, so you have already here on the left hand side some search facets that can be used to select the data sets, to filter the catalog with respect to the criteria that are listed here. So you can select the data sets for a given satellite mission, so the platform. And by the way, when you edit also the data set, please use the CEO's official name for the satellite, because otherwise, with different spelling for the same satellites, this will create different search facets. You can also select by instruments, by processing level, so from level 2P to level 4. Also by the latency, so the availability, the delay, the spatial resolution of the data, the producer, the distributor, or the project that generated the data, and also some label corresponding to the geographical area. For this area, it is also possible to select here on the map a given area, and it will only select the data set which spatial coverage intersect this area in red here. So we may add in the future additional search criteria, such as, for instance, the type of SST. So if you want some skin, foundation, depth, and so on. But that will require you to also to update the metadata in the dataset description. So yeah, so that was a short overview of the catalog. Now I will come back to the main slides. Okay, so we have also a granular search service using the open search protocol. So this has been demonstrated already last year. It was also part of the training that we gave on Friday. So I will not come back on this today, but I put here the link as a remember, and remember also that we provide some tutorial as a Jupyter notebook, which are on the GRIST GitHub website. Okay, so now we'll come to the main topic of this session. So planning the evolution of the GDS. And so there are some minor changes and also major and probably breaking changes. And so it will probably come in two steps, as I will detail later. So what is the GDS and why continue to using? So this is, as you know, the common format for all our SST datasets. And it's a result of an agreement between the different producers. So this is really something that we need to keep on. It allows to provide interoperability between the different datasets, but also the services that deliver or use this dataset. It provides also a clear and unique vocabulary with associated definitions so that we know exactly what we are talking about when we provide SST. As I said, this is an heritage of all the expertise that we gain on SST and all these years of discussion, painful agreements. It helps also to build the traceability through some metadata, so how and when the data were created. It comes also with additional data that are relevant for usage of SST. So in a way, it's less hassle for users, since all the datasets of the same level, at least, can be used in the same way without any code change, and you can switch from one source to another. So it's easy to merge, swap sources, and so on in application. So this is really a benefit that we need to maintain in the future, including with upcoming of new formats that we are getting popular now on cloud, like COG format or the. So the current version of the GDS is 2.1. It was discussed between the GRIST 11 and GRIST 16, so it took quite a while to get there, and we don't want to spend so much time to define the next version of this GDS. So we will propose a new way of collaborating and exchanging about this later in this presentation. And it is accessible from the GRIST website. Be careful that when you search GDS on Google, sometimes you end up on the 2.0 version instead of the 2.1. So we'll make sure to remove any access to 0 version to avoid possible confusion. I saw in some presentation earlier this week that some people were still referring to 2.0 instead of 2.1. Okay, so then what is wrong with the current GDS? So first of all, from the editor perspective, it has become a very big and hardly manageable document, which in some way prevents from updating and fixing the minor things that we still sometimes find in the current document. It also requires different persons. Sometimes you need someone to fix the typo and so on that are created by different word editor and so on. There is a lot of lack of traceability because in such documents that has been living for 10 or 15 years, there is no way that the way of word editor to trace the changes is able to keep up with all these fixes and updates that we do regularly. There are also remaining mistakes, error, and some inconsistencies between the specifications and some example, or between different sections of the documents that provide more or less the same information. So these have been reported by some producers. So we have a list of that, and it's required some additional proof reading. Also, we have moved to NetCDF4 format for many years ago, but we still don't use some of the powerful feature of NetCDF4, such as groups, chunking, possibly also the number of significant digits that you can set up on a variable. So there are things that we can improve to make more optimal the volume, but also the usage of this data set, in particular over the cloud or in distributed processing. The volume limitations that we had before are not so important as they used to be. So we can also relax some requirements that were related to that, such as the extra variables and the packing also of some variables that is a source of error. So this is something to look at. As I said, so GDS was quite ahead of its time some years ago, and in fact, it has been taken as a model by many other projects, so with some spin-offs of the GDS for other domain and variables. So, but now there are new challenges with clouds, and in particular the cloud optimized formats such as COG, NetCDF5, which is not yet there, but may happen at some point there. And so we need to, when people try to convert data to such format, we have to be very careful that we don't lose in the process what was the benefit of this agreed format, which is all the traceability, the naming, the common naming, and so on that we had in the GDS. So we have to provide also some rules to convert the NetCDF4 data to these new formats in a homogeneous way, and avoid that everybody is doing it its own way on different platforms. And also we need to provide recommendation for cloud access to NetCDF4. So that will be the topic of some earlier studies that Ed made and that will be presented after. And last, we need also format checker. So there used to be a format checker before. It disappeared at some point when Podak moved to the cloud. But I heard from Ed that they have now they're preparing also a new checker. And on the GPO side, we also have implemented a light and easy to use checker that I will discuss later. Okay, so given the number of changes, fixes, and so on that we have collected in the last years, so we think that we should have like a two-step process. So first, GDS 2.2 that will be kind of the legacy GDS 2 formats, and that will short some typo and inconsistencies that exist in the current document, provide some clarification and so on. So it will it will have no breaking change compared to GDS 2.1. It will just fix what is not correct. And later, but shortly after, because we will start working on this in parallel, we will address the changes that require more agreement or online discussion, because we don't want to discuss that for hours in the GRIS meeting. So this is something that we need to organize offline. And these changes will probably introduce some breaking changes with respect to the GDS2. So now I will go through a list of issues and changes that we have collected. Again, this is a list that comes from what was reported by some producers to us. I also sent a message through Erika some weeks ago, so that also to call for producers to report what they would like to be changed or to be fixed in the next version. So this call is still open, because this process will take some months. And in any way, we want also to try to involve more people on different aspects of these changes. So the first, one of the first issue is related to the file naming, and in particular with the SST type, which does not fit the new generation of products that sometimes include ice temperature or mixed different types of SST. So we need to account for this mixed surface temperature in the file naming. Also, the product string is causing some issue because of the platform code and the sensor code. And the reason is that for a platform and instrument or sensor, this is based on the COS vocabulary in order to ensure that everybody uses the same spelling for each satellite mission and each instrument. The problem is that with the full name of this mission, this sometimes introduce some weird characters like the dash separators, or it results in too long product strings. So it's very good to have in the internal attribute to have the full and accurate COS name. But in the file name, maybe we need to think to use maybe abbreviations and to avoid these issues, because some people use this separator character to navigate through data files and so on. So if we mix that with other information, it breaks their script. So maybe we will think about adding abbreviation in addition to the CO's full name, and which means that in that case, we will have to maintain some external table to also be consistent across all the missions. For SST types, so as I said, so we have to account for new types of SST. So we need to find to think about a proper way to define these acronyms. So these are some proposals, but this is the kind of thing that we need to discuss in the coming months to find kind of agree on the best way to deal with this multiple water surface temperature in the data sets. So for ice products, so we hope to be able to leverage on all the work that has been done by different teams in EUMETSAT, OCISA, for Siemens that deliver this kind of product, so that they come with some kind of proposals that we can discuss and agree on and then include it in the GDS. But this kind of changes is more like a breaking change, in my opinion, and should go in a GDS3, because it also needs probably some times to be properly defined and discussed. So I put some some tags on each issue to just to affect to GDS2 or GDS3 update, depending on the complexity and the change that it introduces. There are still, for instance, many typos and inconsistencies. This is an example among others, like for the different GPO emails that are still in either on the website or in the examples that we provide in the GDS. We need to clean all that. Maybe also some content is obsolete. So Gimpy is a service and product that is supported and provided by a UKMet. So does it really need to be specified within the GDS? Because this is not something that is shared among different producers. There are also some sections in the GDS, for instance, like regrading rules. I'm not sure that it is followed by all producers or that there is an agreement on this. So do really need to put that in the GDS specification, since this is more like a processing and data issue rather than format. Some practices that we had in the previous version of the GDS, like the packing through the scale factor and add offset, are sources of errors in many cases. First of all, sometimes the data type is or the scale factors are not set accurately, so that the range of value overflows the possible limit for the storage data type. So you have like negative values where in fact you should be in extreme positive values, or you have some kind of clipping. So that's an issue for some field, for instance, like the SSCS. We find that in many data sets. Also, many people don't use them accurately. They look at the scale factor and add offset in dump of a netcdf file, and then they hard code the decoding of the variable using what they have found at the time they looked at one of the files. So if we change these factors later, it breaks the reading of their data, and they end up with strange, unusual values. So that's more an issue of using properly these packing attributes. The reason that they were introduced in the first place is to reduce the file size. So maybe this is not relevant anymore, at least for some variables. And there are also other ways to reduce the file size. First of all, there is internal compressions that provide netcdf4. And there is also the possibility to limit the number of significant digits. And this helps a lot also to reduce the file size. So this is another way of clipping digital values. The only thing that is it doesn't look as nice as scale factor and offset, because the number that you end up with a power numbers that are power of 2. So this is not like round numbers that end after the second or the third digit. It's like infinite floating number. So it's a bit unsettling at first, but it's still an effective way of compressing the variables. So maybe we should allow more free storage types, especially for integers, where sometimes the defined integer, 2-byte integer were not large enough to, or 1-byte integer were not large enough to accommodate the whole range of value. So we should be less strict about that, especially since now for people who are used to scientific packages like X-ray and so on, all this is decoded on the fly when opening and reading data files. So you don't really need to care what was the data storage type used, because you end up anyway with floats. So there is a trace study to be done to assess the impacts of these different possibilities, and in particular replacing the packing with other ways of compressing the variable. Groups is something that was introduced in netcdf4. It was already in HDF5, and this is something that you have not used so far. And so what the groups allows is to put together some variables that have common meaning or that are in the same coordinate system. So, for instance, it can be a purely cosmetic way to put together variables like that are related, strongly related to each other. Like in a core group, we could put the SST together with associated quality and uncertainties, while the ancillary field like met fields and so on, or experimental fields would be in other groups. So that's one use case. Another use case is for sensors that have a multiple view, like a SLSTR, where you could have a different group for the nadir and oblique view, for instance, and each one with its own quality level and uncertainties. And another case is when different SST field may have a different coordinate system. And this is the case, for instance, with L3S. If you merge into the same L3S microwave data that have, of course, resolution, geostationary, and high resolution polar orbiting data. So you end up with possibly with grid with different resolution, and that would either you put this in different L3S, or if you want to put all that in the same L3S, we should use a group and with for the different source of measurement and with their own coordinates, latitude, longitude, and so on. So one issue that we have to address in looking at this is not to be too specific, so that we keep what was the benefit also of the current format, which is to have a consistent naming and the easiness of swapping products and changing without any change to do in the code. If we start to have different groups with a specific name, it could be more messy for the users to use and switch from one sensor, one product to another. So you have to be careful about that also when addressing this, even if grouping is definitely a powerful tool. Also, additional information have been requested along this year. So, for instance, like the total water vapor content. Also, there are many suggestions about replacing the SSES with proper uncertainties. A lot of work was done about this, for instance, in the CCI project. So again, this is we could leverage possibly on the definition they came with, the name of the variables, and so on, to kind of have an initial proposal that we could discuss and include in the next GDS 3 version. As I said before, it's not so critical today to add additional experimental free fields because volume is not so critical as it used to be. So we should simply maybe lift off this constraint. Also, we can think about adding more traceability information on the processors, versions, the processing steps, and inputs that have been used to generate a given data set, either in the .cdf itself or in some annex manifest file or something. I think we need also maybe to think about this time variable. For instance, for L2P, it was split in two variables, like time and SSTD time. This does not really make sense for level 2P data, and this is not properly recognized by the tools and the libraries that we use to read the data. So we have to explicitly each time add these two variables to get the proper pixel time. And there is no real necessity for that anymore. It remains meaningful for level 4 data where you want to stack a cube of chronological fields. And also for some level 3, whereas maybe for some other, it may be also questionable. So this is something also we need to discuss a bit. Also, we should relax the constraints on the reference time, which anyway was not really followed by everybody. And again, this is an issue with some users that hard code this reference time when reading the data. So this is something we have to try to prevent, and also allow more precision in the unit as needed by the data producers. Coordinates. So the CF convention has been greatly improved in the last year regarding all the spatial coordinate information. So maybe we should consider also to update this aspect in the data product, and in particular, for instance, for a gridded data set to properly describe the projection and the CRS in which the data are projected, documenting better also the latitude, longitude, what they refer to, what are the bounds of the cell, what is also the accuracy of this information. So we can think about many additional information for that. There are the CF conventions define additional attributes like the cell method that describes how pixels in level 3 and level 4 were averaged. So we could also refresh the GDS with respect to that. And then we have also the issue of upcoming ultra-high resolution missions, and with the question whether we should really store a full lat-long matrix instead of using, for instance, like type points, as they do in a lot of high-resolution imagery or SAR data. So again, something to think about. An important thing is the internal checking of the variables. So NetCDF provides the possibility to change the data. So it means that you gather data in from a big two-dimensional or three-dimensional array in smaller subsets. So it's transparent for the user, but this is directly related to the optimization of the disk and the size of the blocks and so on. So this is really to speed up the reading, the subsetting, and the distributed processing of the data. So when you create, most of the producers that currently create this NetCDF4 data, they use the default values that are provided for these chunks. And the preliminary studies by Ed and others show that this is really important to take care about these settings, and to therefore for us to provide some guidelines on how they should be set for a given data set for optimal usage on the cloud or on a high-performance computing platform. So chunking is something also that we can do afterwards. So meaning that for a previous data set, we can rechunk them without changing actually the file content. So it means that this is something that we can optimize past data set as well when we put them on the cloud, if we properly set this chunk sizes. So it applies also to all the data. There are some attributes that are not always, we don't know if they are really used and if they are still relevant. For instance, there is this file quality attribute that applies to the whole files. I'm not sure many producers care about this attribute, and I think most of the time it's hard-coded to 3, so to excellent. Some producers do use it, so they put like the value 2 in the first months of a new satellite mission, so during the after launch and Calval phase, for instance. So either we should remove this attribute, or at least we should better clarify its usage and how it should be set by the producer on which ground. So now I come to the editing process of the GDS itself. So we want to deal with that in another way. So as I said, the main reason why the GDS document became hardly manageable today is that it's a big Word document, so it goes through different Word editors. It's difficult to share the edition of this data, of this document, sorry. So sometimes even in the current 2.1 version, I saw that we lost some images in probably trying just to clean the document. So all these issues are hard to recover and to clean afterward. Also, it's like a document where you would put some Python code or whatever, something that is not full textual information. Inserting, for instance, extracts of NCDump, so of the file format in a document is a bit a nightmare to manage because of the way the Word editor will reformat this. And so this is not really the way to include such external information in a document. It's very difficult to keep a history of the main changes and version. Sometimes it's not properly tracked, or it is lost because this document has been living, as I said, for almost 20 years. So and we cannot keep a huge history of all the typos and so on that have been changed since that time. And most of all, it's not really practicable for collaborative work. And in fact, it always ends up to someone to volunteer to maintain and fix this document and to get some help from more like a secretary to clean up and find make it more beautiful in the end. So this is not a process that allows to quickly discuss and update the GDS in the coming months if we want to go on a fast track about all the changes I've mentioned before. So there is we need to engage the different grease producers and more people that have interest in the new stuff that we want to add to the GDS. And all these updates needs to happen off meetings, so online basically, as we don't have time to discuss all these issues in Greece, and usually it requires some thinking and so on. So it's not the proper way to discuss and progress on this. And also from the user perspective, this big 160-page PDF document is not really easy to navigate. It's difficult to go through the different sections and to go through some from the main description to the examples and so on. So it's really hard to find. It's not. This is the kind of document that it's not like it's not a novel. This is something that you read like in a sequential way. We need more interactivity, links and cross-references and so on to really go to the fully relevant information for the producers who have to quickly deal with the formatting of his data. And as I said, there are many inconsistencies that result from the difficulty to edit this document and to collaborate on this. And this makes also the life of users difficult because there is some confusing information sometimes. So we propose a new way of working on this, and it's a bit like working on like in the Piolle world, so working like on a shared open source software. So having the document under a GitHub repository, like you would do for a software, and then to manage the changes and the exchanges, the discussion about these changes through issues that can be tracked within GitHub. So this is an example on the right, where for a software you have like a list of issues with their own threads of discussion, and you can assign people to implement a specific issue, or at least to come with a proposition and discuss online, then merge the different contribution and so on. So this is really the way that we want to experiment, to move on more quickly with update on of this document. A benefit also of putting this in a GitHub is that you can automatically manage version, so release tags, generates a full document automatically. You can also come back more easily to previous versions through the different commits that have been tracked in the GitHub. Also, so we want to use a simple we don't want to use anymore like a word editor. So go through, for instance, what we suggest is to use a Jupyter book style of editing. So this is simple text with a few markers that you need to know to properly define the titles and tables and stuff like that. But you don't have any more issues with formatting, with fonts and size and so on, and all what happens when you go from one word editor to another. So I just have we tried to initiate this just to show how it would look like for users in this kind of version of document. Okay, so basically we took what was in the current GDS, and so you have now on the right like the different section of the document. So you will have, for instance, the conventions of the document, the different. So this is a new section, the definition of the different sea surface temperature. For instance, this table is not anymore in the latest GDS version. It was somehow removed in the last cleaning. Then the conventions for file naming, so you can go directly to navigate through the different sections to see the information about a particular field within this file naming convention. Here, this is an example for level 4. Where you have the current list of variables. The code, the NC dump that you see here is not in the document itself. It's really taken from an NCDF file, and it's the NC dump is included in the generation of this document. So it allows also to prepare some example of template NetCDF files for each product level that can be used also as an additional resource in addition to the GDS itself, because you will have like a full example of file for each level properly formatted. So we think it's a bit more easier for a user to work on their product formatting based on a kind of HTML document like this. So how does it look like? So basically, the Jupyter book is made of different files for different sections of the document. And this is basically a textual document, so really a text document with a few so this is markdown language, so it means that you have a few specific markers to identify the titles and some specific formatting things, like including a figure, a table, and putting a caption and so on. So it requires a little bit of learning about this Markdown language, but honestly, I didn't know about this, and when I initiated this document, it took me a couple of hours just to figure out what the markers that was needed. But now with already defined these examples, we basically, it's much faster, I think, for someone coming and trying to add content to see how it should be done. Okay, so now about the proposed timeline. So we want first to address this ultimate GDS 2 version. So these are mostly minor fixes, and that will be also the full conversion of the Word document to this Jupyter book. So hopefully that should be fairly quick to do that, and we will aim at early this fall to deliver this GDS 2.2 version. And in parallel and after, we really want to start working on the version 3, addressing all these issues that I've listed before, and also in a transparent manner, so that every issue will be accessible to all the science team. And everybody is welcome to participate to the discussion of the different issues that are items of discussion that we will identify and to contribute. So, and we'll probably also call to science team member to get their advice and so on some specific aspect when consensus and agreement is needed. So it will happen through online discussion through this GitHub repository. So ideally, we could have an early draft by the end of this year, aiming at a more consolidated release for the next GRIST meeting. We have, I think, already a lot of material that we can include. All the things I've mentioned about uncertainties, about ice temperature and so on. People have already worked on this, and they have proposals to make. So what we need is to agree and discuss and include all this. Okay, last thing for me. So I mentioned before that since we were lacking a GDS format checker for quite some time now, we implemented a new one in Python. So this is a very light, portable Python package that you can install with pip. And it allows to check the format of each product level in a GRIST GDS. So this is currently under development. It's funded by Copernicus through UMETSAT, and it will be available also on a GRIST GitHub repository. So basically, it's a simple Python script with very few dependencies. It's based on a YAML description of each product level where you list, in fact, what is in the GDS, so the list of required or optional variables and attributes, the allowed variable types, and the allowed values in the case where this is kind of enumerate information. And all this is checked when you give a file as input to the script. So this is very light and simple, nothing fancy. So these are examples for two data sets that I took just randomly. So for level 2P, so one is from VIR. So you can see that you have some warnings and some errors where mandatory information is missing, or when, for instance, platform name is not really compliant with the COS vocabulary. We also check do some sanity checks like the latitude, longitude. We verify that they are between minus 180 and 180, that there are no undefined lat long or time values, and a few things like that. We also check the compliance of the format of the file naming. So it will report when something is wrong in the file name. This is the case here because of some additional segregator that includes a dash character. Okay, so maybe so GPL is also working on his side on a checker. I've heard from Ed, so maybe I'll leave you the floor for this, because after it's about the chunking.
One thing I wanted to ask you, John, we covered a lot of ground, including one called radical proposals, but big changes in the GDS. Do you want to maybe open the floor to some discussion and feedback on some of those things now, or wait till we're kind of done in 15 minutes or so? Well, we're the leaders, so we decide. Maybe we'll take 5 minutes. Does somebody have some thoughts or comments about what, the ways forward we're proposing here, or concerns? Are there any concerns, or you just going to leave it in our hands and take our proposals and accept our proposals and we'll start implementing them? Go ahead, take the mic up there.
Hi, Ken Casey, NOAA and CEI. Yeah, so I really appreciate this very thorough examination of the GDS. I think I like everything that I saw that was presented. I mean, obviously we'd have to go through some of it in more detail, but I really like sort of, moving out of like the traditional document space and getting it into a Jupyter book, things like that, because as some of us well remember, it was, many painful years. So I guess I'm just sort of giving a voice of support. I really like what you guys have done here, and be happy to help as we go through the process.
Okay, thanks for those positive thoughts.
Yeah, thanks. It's come a long way. Thanks so much for moving that forward. And I know we definitely need to give you a lot more information. You've been reaching out. So I think at the beginning when you showed the catalog component, it would be nice to move the region that's at the very bottom up front so that people can maybe quickly peruse some of the regions and some of the SSTs. But it's come along so far. So thank you so much for all your efforts.
Owen.
Owen Embry, University of Reading. Yes, use GitHub and issues for tracking. That's a very good idea, and I support that.
Yeah, I guess if you wanted to participate in this ecosystem, you had to be familiar with using GitHub and GitHub issues. But I think once you start doing it, it's just you learn how to do it. Okay. Oh yeah, Prasanjit.
Yeah, Prasanjit, you just said, okay. Just following up from Ken, I'm not even sure it's a valid question, Jeff, but this markup language based documentation, can you handle equations? I know that there are not too many equations in GDS document, but if there are, can it handle those equations properly?
In fact, yes, because Jupyter book are used a lot now for courses, for teaching and so on. You can include also Jupyter notebooks, so not books, but notebooks. And in notebooks, you can, as you know, you can add also equations and mathematical notations as well. So yes, it's
okay. So that's a yes.
Yeah.
Thanks.
And actually, just Garrett Graham from North Carolina Institute for Climate Studies. To add on to that, the Markdown in Jupyter notebooks, you can actually include LaTeX style write-ups of equations in addition to the coded versions. So you get really the best of both worlds. You get to see it implemented in code, and then you also get to see it in like actual, typeset form, which is quite nice. You mean coding the equations, or? It can be. There's online converters for being able to write out that will actually convert an equation into LaTeX for you, which is quite nice. But anyways, we can talk about it in a bit. Yeah, the idea, the using GitLab or GitHub or Git in general for version control and then also for tracking issues sounds really awesome. One tool that we've been using at the Institute in North Carolina that kind of layers just a little bit more on top of that, but infinitely increases like the power of or the power of Git is using it's called Overleaf, and it's some people in here might be using it, but it's an online LaTeX editor. And so it interfaces with GitLab. So all of our documents, like if we write papers or whatnot, we're writing them on Overleaf. It's in LaTeX, but you can also write it in sort of plain text format, like what looks like a Word editor, and it immediately converts it back to LaTeX for you. You version control it with Git, so you can actually do issue tracking and stuff, but you get all the benefits of essentially kind of a like Google Docs almost, but with the power of LaTeX and the power of Git. You can also render it into a website pretty readily. You can render it to Markdown. And so that might be another, I know it's one additional thing, and it sounds like this has been a tremendous amount of work just to get it into the Markdown space, but that's been a really useful tool for us. So I thought I'd just mention it.
Yes, thank you. It's relevant, and there are also probably when we start this editing process, we will also give away some tools like this that you can use. There are also some tools, for instance, to more easily manage tables, which is a bit weird in a Markdown language, but you can do that online also with some tool to convert from an Excel sheet into some online interface, and you get the proper Markdown version of it. So we will provide all these tips and additional tools that may ease also the life of the editors.
I didn't even realize you got down to the HTML pages until I saw it today. So there's a lot of hard work he's done already to prep. Okay, so I guess we're hearing lots of positive thoughts about the roadmap forward.
I had one other thing I just just to bring up real quick, the chunking, starting a conversation on the chunking.
Yeah.
That sounds awesome.
We're going to get into that in a few minutes here. So hold your thoughts on that. I'm going to give a little overview, or you've already had a little overview, but I'll dig a little deeper. Go ahead, John.
John Mittaz, University of Reading. Just about the uncertainties, as you may expect, I may have an opinion. I'd just say that I think the CCI has uncertainty mapping for its time was fine, but things are developing, and we've even had discussions already in this meeting about correlation length scales and things like that, which add an extra layer of complexity. So it's the uncertainty, how you parameterize that is certainly not a solved thing at the moment, but it's good to move in that direction. I mean, you can start with the CCI thing, but probably in a time scale of 5 years, it may be completely different because we're actually concentrating on other aspects of it.
Well, that's a good point. And we'd be depending on the expertise in the room to help guide the development of that, evolving section or new requirements in the GDS. So we'll take one more and then we'll move along. We want to save at least some time for wrap-up discussions as well. And I have about 15 minutes to present. Go ahead, Ken.
Yeah, Ken Casey. No, again, is now the right time to make any other specific recommended changes, or do you want to save those for another time?
Maybe we'll save those to the end. Okay. I mean, do they have to do with this kind of material we presented, or?
I have an idea about sort of what to do about climatologies, or, sort of requiring something to do about climatologies based on the the discussions earlier in the week.
Yeah. Maybe we'll hold that thought so we can get to the rest of the presentation, but that's a good one. Okay, so we just back up one slide there. Just, there's a metadata compliance checker. It was around for a long, long time, and we had to deprecate it because it lived on an on-prem machinery, but now we've got it rejuvenated, and it's running in the Earth Data Cloud, and we'll release it publicly in a few weeks. And so if you remember, it does CF and ACD compliance metadata checking. That's the main thing, but there was actually an add-on module that just did compliance similar to what Jean-Francois showed for GDS 2, level 2P, level 3, and level 4. So that'll be another tool in our toolkit. Okay, so what I wanted to talk to you was about some best practices and stuff that I've been working on. Next slide, please. With regards to NetCDF, and I mentioned, I do the slides. Sorry. For NetCDF in the cloud, so most of this work was based on HDF, but of course NetCDF does follow the HDF5 data model. So there is overlap to what I'm presenting and what we could potentially do here. Caveat that much of this work is in progress, and really what I'm going to report is not strict guidelines to optimize right now. This is work in progress, and even some how to implement is not quite straightforward. But I do believe that some of the practices that I'm going to report here could have a positive impact on working with GRIS data in the cloud. And there's really two key practices I'm going to present here. One of them is this idea of optimizing the internal metadata page size to improve access and streaming of the data in the cloud. I'm going to describe exactly what that means here in another slide. But the goal, the benefit here is to reduce the latency to read data that's in the AWS cloud, or really any cloud. And the other practice I'm going to talk about is on the data chunking. I do have some information there that I think is important for us, and of course, chunking is besides improving access for like tools and services and subsetting like OpenDAP, it will be important for the creating of these virtual stores like Kerchunk or really any kind of data aggregation service, and overall, just improving the cloud experience again. All right, so cloud optimization for HDF and NetCDF background. So HDF5 was built in the pre-cloud era when you had data on the local disk, really, and the reads were fast and cheap. You didn't really worry about the number of read operations. They weren't really particularly high concern, but this paradigm of data in the cloud with the object store and the key value interface, these reads become longer, much longer, and they're expensive. And so we want to minimize the quantity of these reads as best as possible. And why this is important is because the HDF5 library and Python package like H5Py, they need to read what's known as the internal metadata before they can figure out where to go in the file to actually read data. And by default, these internal metadata are in these little 4K snippets that are randomly scattered over the file. That's just part of the design of HDF. And again, back in the day, they didn't worry about the read access because it was down to milliseconds, and they could quickly read these little 4K snippets and go into the file. But this is where the issues arise when you try to read these products in the cloud, because the entire metadata contents, again, must be read before any really file I/O can be done. The file metadata, this is not when I talk about this metadata, I'm not talking about the climate forecast or the ACD metadata that's in the header. This is the file metadata that tells an HDF5 reader where to go. In other words, the byte offset to read or write a variable of interest or a chunk of data. All right. And so what does this look like? And okay, so what you can do, there's a way to get around this, and this is the paged aggregation methodology, where you're taking all these little 4K snippets and you aggregate them into a larger chunk that you can just thus read just once. And by having one read, you can figure out exactly where you can go in the file. And these are just little code snippets of how you would do this. It's just simple. When you write an H5 file, this from the H5 Python library right now, this is what you do. You call it, and you just have to add this attribute fs_strategy and set a page size on the order of a power of 2. And I'll get into a little more about what those sizes need to be. And of course, when you read it, then you have to turn on what's known as buffering, right? And you have to read as a power of 2, the same size or a power of 2 bigger. And you can see what we're doing, what this is doing here is kind of similar to how the way Kerchunk works, or ZAR, where you have an external lightweight JSON file that contains all the byte offsets. And that's what your ZAR or your Kerchunk reader would read before it actually dives down into the data store to pull out data. So yeah, what does this file metadata look like inside the file? And of course, you can use the H5 stat command to drill inside the file. And this is what it reports for a file that's not optimized. In this case, we're looking at an ISAT2 granule. So this is a large 1 gigabyte H5 file from the NASA ISAT-2 mission, and you'll see the file page size is 4K bytes, but the actual total metadata is 4 megabytes. And so this is the issue then when you have this granule on an S3 bucket, and when you want to read it with an H5 library, it has to traverse the entire file and find these little 4K snippets before you can read any variable or any chunk inside that variable. And believe me, it sounds like it's trivial, but in the case of this particular granule, it takes minutes to fully traverse that file if you wanted to read every single piece of it. And I'll show some performance results that demonstrate that. So with that page aggregation strategy, though, you can rewrite that file or recreate that file. You can actually use the H5 repack command after the fact to change this file and turn on what's known page aggregation. So we want to actually take that file metadata that's on the order of 4 megabytes, and we want to set our file page size to be something similar, right? So in 1 or 2 reads, we can read the entire metadata content. So we don't have to read it hundreds of times. We're just going to read it once or twice. So here we're using the H5 repack. We're going to set a page size of 4 megabytes. We have to set these things exactly. The power is up 2. And you see once we run the H5 stat command on this repack granule, then now the metadata is the metadata page size is on the order of the file metadata, the total file metadata. So in just 2 reads, we probably should have set that to 8 megabytes, but in this case, 2 reads, we can get the entire metadata contents. Okay, there's a performance test that, okay, so yeah, what the point of this slide is that the H5 repack, you can use this H5 command line utility on a NetCDF4. You know, NetCDF4 is a valid H5 file, and it will maintain the NetCDF4 structures and rules and have a valid NetCDF output. We've done this. I'm going to show you a test now, or an operation where, or a test case where I've applied the H5 repack to a NetCDF granule. And I have this performance program that I got from my colleague in the HDF group, Alex Jelinek. It's just a simple program that opens the file, and it doesn't read data, but it reads all the storage location. And so it reports the wall clock time of that complete end-to-end operation. So that's kind of the de facto test of traversing the file and showing what the effect of reading the file without metadata aggregation and with metadata aggregation. So one thing I will say about NetCDF that you probably already might have already guessed is that this page aggregation feature cannot be turned on at the point of file creation with the native NetCDF libraries, right? And so that's a significant drawback. I don't know why the designers of NetCDF did not inherit that feature from the H5 library when they designed, the NetCDF data model and library, but that's what we have right now, unfortunately. So I'm going to show you a little results of a performance test. So this is a SWAT. LLC pre-SWAT data. It's a 5 gigabyte file, and it's pretty simple actually. It has 1 group and 45 data sets. So it doesn't. I mean, the metadata is a factor of the complexity of the granule. So the more groups that it has, the more data sets and variables, the more chunks that it has, the bigger that a file metadata will be. So in this case, we're under 1 megabyte right here. So it's not that big, but it's still possible to optimize it. And what I've shown here, there's 3 columns. The first one is the file page size. So the first row is the original size. That's 4 kilobytes. And then we have the buffer size and the runtime total from this performance test, this end-to-end reading of the storage location offsets, and we're just wall clocking that. So the original one, with no page strategy implemented, we put on an S3 bucket. It takes 5 seconds to traverse that entire file. But if we optimize it with 2 strategies now, 524 kilobytes or 1 megabyte, we're down to less than a second. So we've had a 5x round trip improvement. It's a modest improvement. I've seen other granules like that ISAT granule. We're actually going from minutes down to seconds. So again, the improvement you see is based on the complexity of the granule. You're trying to improve this metadata aggregation technique. So I would say this is a pretty positive result. Another result I think I have is from Muir, which is a reasonably sized granule. This is Muir now, so this is a 750 megabyte granule, and I've gone down from 2 seconds with no page implement strategy down to less than a second. I did want to point out in some cases the file sizes grows. And so in this case, these are growing 10% larger. So that is another that is a negative impact of having larger file size. All right, so I mentioned that there's no way in the NetCDF library natively to do this. You can use H5 repack after the fact. If you're clever enough, you can use the H5 HDF library. If you know what you're doing and respect NetCDF rules, you can use that library and write out a valid NetCDF5. But you know, unless you know what you're doing, you can make a lot of mistakes there too. One other avenue I've been investigating is using this Python package called H5 NetCDF, which is the Pythonic interface, NetCDF interface to H5 Pi, as another possible methodology for creating and turning on this page aggregation with NetCDF. But I haven't really dived too deep in it. I'm just posting that for your information. All right, I think that's all I had to say on this. Oh, I wanted to mention that I had this summer student working on a very clever little project here, where he kind of extended beyond the Kerchunk domain and actually started using what's known as these DMR++ files that are used in the cloud version of OpenDAP. And every single granule that the PODAC produces, including all the granules that we ingest for GRIST, have these DMR++ files. So what are these files? Again, these are very lightweight files that have the storage locations of the granules, the byte offsets to variables and chunks inside those variables. And so he's come up with a clever way of working with this group in the NSIDC to use this package called Earth Data Access and actually modify it so that it can aggregate those DMI++ files to have a virtual metadata store similar to the Kerchunk methodology and stuff. And he's had some really positive results. He's demonstrated using SWOT data. Unfortunately, I wanted to get a demo together, but unfortunately, I wasn't able to get it in time. But I think by next year, we'll very soon we'll actually have a tutorial on our GitHub site using this approach. So I think this could be another avenue. We haven't talked about Kerchunk or something like this, but that would be another avenue of optimizing GRIST products that are in the cloud. All right, yeah, this is my last slide. So did I have something on chunking? Thought I had a slide dedicated to chunking, but I guess maybe I dropped it or something. But here, this really kind of summarizes the points I wanted to say about chunking, right? You really need to think about the use case, the user use case, when you're designing your chunk sizes, and you can't make one size fit all. Unfortunately, you have to either consider if you want to do chunking in space or versus time. You know, large spatial subsets versus smaller regional subsets that are more for time series analysis. So those are the two kind of use cases, typical use cases. When people are trying to access just pieces of the data, right? Sometimes they want to access a very small little point through a long time series. Other times they want just larger subsets that might be more randomly scattered in the granular time series. It is important to keep in mind that for data that is in AWS, these get range requests for really anything you want to do to get data in object store is best when it's in the range of 18 to 16 megabytes, right? So if your chunks are kind of on that order, you're kind of in that little sweet spot for AWS. It's important to realize that too small chunks can hinder I/O. So what is too small? I would say something on the order of kilobytes is too small. And you know, too big, if they're too big, they're not that useful then for the time series application use case. My personal opinion is that really something on the order of 1 to 20 megabytes, I think maybe is kind of like the good compromise location for meeting you know, the needs of these two use cases, as well as, you know, being in line with this 8 to 16 optimum get range request for AW once that granules are in AWS. Okay, that's all I wanted to say about chunking. And on the page aggregation that I described, there's really the workflow to do this is determine the size of the internal metadata, set the page size to be 1 or a power of 2 bigger, and then set these chunk size, set the chunks to be equal. I should have said the buffer. They need to be equal or a power of 1 or 2 smaller. And the file size can grow slightly that we've seen, so that's a negative impact. And I will report that too, that my colleague in the HDF group, Alex Jelinek, who's really kind of spearheaded this work, his performance results show that kind of like the 8 megabyte page size is the one that's really is the one that's good for overall performance. So I think, yeah, so I guess my message here that it's premature to implement this right now, this page aggregation feature. I think it's something we need to keep on our radar screen. This kind of technology, these things are really kind of changing like month to month, to be honest with you, as we get more information and more experience. We have implemented the page aggregation in the NISAR mission, but that mission is pure HDF. So, you know, the HDF5 library has no problems implementing this strategy, this page aggregation from the get-go. But I guess we have to tread a little more carefully because we're in NetCDF, so it's not quite clear the roadmap for implementing this page aggregation feature in NetCDF, even though it seems to appear to bring great benefits. Okay, so I think that was it. I think yeah, that was it. And which time do we have? I mean, that's not it, right? Now we're going to discuss some more, and we still have 15 minutes. So maybe they'd take 5 minutes to any feedback on what I just presented. I think Ken, you had some questions on data chunking. Maybe we can just start the discussion there. Owen, why don't you go first?
Has the page size issue been raised with the NetCDF-C developers?
I'm not sure it has.
Because
yeah, I haven't raised it personally with them. I'm not maybe as close to them as I should be, but I think they're aware of it.
It could be worth just opening an issue on the GitHub page saying, well, referring to whoever's done in the HDF group that's done the work, showing that making it to this size gives you this performance increase. Because presumably that's a good effort to add it as another option in the C library should be relatively minor. It's just
you would think so. You would think so. Yeah, I mean, let me take an action of just opening up a GitHub issue on this and see what their response is. I know that the Unidata folks they're kind of like a little understaffed, and you know they don't have many resources and stuff. And there's been other, I guess, issues with the NetCDF library and other tools and stuff they haven't addressed. So I don't know if that's a factor in their kind of response to this.
Well, it is open source, so possibly other people could contribute a pull request to do it.
Yeah. Good point. Thank you for offering that.
Veronica, Lance, Noah, could you just clarify when I missed it? You said you cannot implement it when, so you can't go back and reprocess metadata to do existing net.
So if you have a NetCDF granule, there's no way, if you want to produce a NetCDF granule, there's no way to turn this on natively at point of production right now in using the NetCDF, C or Java library. So you have to use after the fact thing like H5 repack, or possibly you could create the granule with this H5 NetCDF Python package. I'm not sure if that's a success story or not because I haven't really dived too deep into it. But again, when you go to their GitHub site, they say they're experimental, right? Which is kind of raises a little bit of a concern and a red flag.
Thank you. My understanding was backwards. So you can do this repack to an existing thing. You just can't run one from the
right.
go.
Yep.
Thank you. And then one other minor question. So you showed the performance and the decision as to whether to go to the two times or the one time, but you didn't show any improvement in the time. So
no, I show an improvement here. This one is a 5 times round trip improvement. This is the LLC granule 5 gigabytes, and the other one Mirror was a factor of 2.
So I don't understand the trade-off. Like, why would you do one or the other? And
you want to reduce that latency time to reduce the time to read data inside the file. Time is money.
Yeah, the difference between the 2 bottom ones.
Oh yeah, there's not much difference. The 2 last rows are the different page sizes. So in one case, I pick a page size of 262 kilobytes, and in other case, it's half a meg, 524 kilobytes. Didn't really seem to make a difference at this point. But the point, yeah, you want to make your file metadata, your page size, at least as big as your file metadata, or a power of 2 bigger.
You tried to.
I know, throwing you a lot of information at you guys, but
in your test, it was you were reading a full file. Did you try also?
I'm not reading the file. I'm just reading the storage locations, and you need to read those storage locations before you do anything in the file. So that's the that's the test. And you to do the wall clock time to read all those storage locations. Ken, did you want to maybe discuss or ask more questions about this and on the chunking?
Yeah, Ken Casey, Noah. I had a couple of comments. First of all, yeah, those performance improvements are really cool, but that 10% larger volume, that could be really pricey because you have to pay that every month.
Yeah.
So that's something I think would really have to be sorted out carefully.
Right.
I didn't really have anything else to say about chunking. I had a completely different suggestion for the GDS. That was about climatologies.
Yeah, maybe we can move on.
Okay, all right. So, a lot of the conversation earlier in the week about like the use of our data and ecosystem applications, and that's something I've long been interested in, having done a lot, particularly earlier in my time at NOAA. And so all of that conversation got me thinking, well, maybe one of the things we ought to require in the GDS 3.0 would be for every product to specify explicitly the most appropriate climatology to use for that product, so that our users don't have to figure that out on their own. And that could help with a lot of this, if you're really trying to calculate good anomalies and then thresholds and, degree heating weeks or whatever whatever for your particular ecosystem of interest. At least and those are often users who don't understand all the nuances in all of the different products. Mm-hmm. So I don't know if it would just simply be a metadata requirement that says, this is the most relevant climatology, but I think it's something we might want to consider for the GDS 3.
That could get a little controversial, though.
In what way would it be?
Well, I mean, there's a lot of climatologies out there and stuff. So,
well, yeah, I was thinking it would be for the data producer to determine. You're probably using a climatology and you're cloud masking somewhere, anywhere already. So you as a data producer, you ought to probably know what the most appropriate climatology is for your product. I would think. Mm-hmm. Yeah. I mean.
Okay. Yeah.
I would tend to think also that maybe this is something that should not be in the file metadata, but maybe more in the catalog, in the description of your data set.
Yeah, that's what I meant. Like, it could be not sort of a required part of like the collection record or something like that.
And I think the proposal to like improve the description of the cell methods for like level 3 data sets would help people that are developing climatologies to kind of understand what's going into their information. Anybody else? I guess the floor is open to all topics.
Owen again. Speaking of climatologies, we could add a climatology section to the GDS.
So that would be like a best practice how to create a climatology, or what are you getting at there?
The specification. So you've got L2, L3, L4, but there isn't a specification for a climatology in there.
Mm-hmm. I see.
It'd be things like the copying from CF conventions for the climatology bounds and so on, how to set up the time and that.
Yeah, this is Ken again. I would second that. And I know in the past when I was producing like Pathfinder and corresponding climatologies, we were kind of having to sort of force it into the GDS because we wanted it to be as GRIST compliant as possible. But we didn't have a GDS specification level for climatology. So I would second that idea.
Mm-hmm.
Just with respect to the question of the climatology, scientists is wanting to make sure I understand. Are we talking about, in terms of GDS, are we talking about each data provider providing a climatology based on the data set, or providing a climatology that's already been decided upon as a standard or reference?
I think it was more a recommendation of what existing climatology to use for a certain data product.
Yeah, I think Ed said it right. It would be, me as the producer who knows the data better than anybody thinks this is the right climatology to use. So, that would be most consistent with that product. It doesn't mean somebody can't use their own climatology or something completely different, but it would make things simpler for, the average user.
Anybody else?
Garrett, did you have anything else you wanted to add about the chunking? No. Yeah. Yeah. Right. Just as long as you don't make it too small, and then the file I/O can be negatively impacted, right? But
Okay, so yeah, maybe we can close the session. So anyway, we will get back to you very soon about this GDS evolution. We will really need the help of everybody, as many, at least to agree on the things that we are proposing on the changes and to review them.